went and asked for the lecture notes. So she got all the lecture notes and she started reading and studying more maths on her own. And she really became incredibly good at the maths that she was busy doing. But now she needed to check out, you know, some of the maths she was doing, because she was really starting to develop new mathematics, right? She wasn't just practicing, you know, factorizing quadratics or whatever. She was actually starting to develop new mathematics in a field called elasticity. And so she needed to check whether this new mathematics that she was starting to develop was actually useful, correct, good. So she needed to get in contact with some of the lecturers at the university. And there was a very famous maths lecturer at that university, a man called Lagrange. And if you carry on to study mathematics at university, you will come across all sorts of times where you will find the Lagrange multiplier, the Lagrange integral, etc., all named after this very famous mathematician. So he was very famous. She wanted to correspond with him, check out whether what she was doing was okay. But when she wrote the letter to him, she thought, if she puts her own name there, he's just going to chuck it in the bin. Why? So she made up a man's name, and she signed all her letters by the man's name. And so he started reading her work and saying, wow, this is really good, this is amazing. So then he said he sent her a letter saying, please, come and meet me. Now she's in trouble, right? Because she told him she's a man and she's got to go meet him. Luckily, Lagrange turned out to be a progressive human being. And so when he met her and discovered that she was a woman, it didn't matter at all to him. He only cared about the fact that the mathematics was interesting and good. And they ended up doing work together and discussing a lot of the mathematics together. So that is kind of the story of Sophie. Before I finish the story of Sophie, I'm going to get you to have a look at one of the very famous pieces of mathematics that she worked on in her lifetime. She unfortunately never solved it, but she certainly made some progress on it. So, have any of you heard of Fermat's last theorem? Okay, so this is a great story. And if you ever have any time, you should Google it. And there's a really nice sort of documentary series on it, and there's nice stuff written out about it. It's a fun story from the history of mathematics, right? So Fermat, again, I seem to have got us stuck with the French, but Fermat was a French mathematician. And he was around in the 1600s, so even earlier than Sophie. And he did a lot of work, but he had this habit of doing all his work in these sort of notebooks, and then he'd scribble little notes in the side. So he made this statement, and we'll go through it, right? But he made the statement, and he said, he wrote in the margin, I have a wonderful little proof for this, but it is too large for me to put here in the margin. In other words, he was saying, I can show that this is true. I know how to show it's true, but I just don't have enough space to write it down right here. So everybody thought that he had managed to show that this was true, but just didn't have enough space to write it down. And now remember, this was in about 1670, right? A long time ago. After that, mathematician after mathematician after mathematician tried to figure out why this is true. They tried to figure out why it is true. Do you know when someone finally showed that this was true? 1995. Yeah. It took over 300 years for people to find a way to show that this was true. Even though Fermat wrote, I know that this is true, I can show it, I just don't have enough space. We all think now, he couldn't, he didn't. Because when the person who finally showed it managed to show it and prove it, you've done proofs, right, in your maths? Yeah? Yes. Have you ever written a proof that's 300 pages long?
No.
That's how long the proof of this is. Can you imagine? 300 pages. Yeah? Okay, so let's look at what the statement is, because it seems, I mean, that's why I think for many mathematicians, oh, by the way, do you want to know the man who finally solved it is a man named Andrew Wiles. He's still alive today. And let me just check I've got the numbers right. Do you know how much money he won for proving it? 12 million. Pretty nice, eh? Imagine. Okay, so let's look at what this says and let's see if we can read the mathematics of it. What this thing is saying, right, is if we look at x to the power of n, you know what that means, right? Yes. Plus y to the power of n. It's equal to z to the power of n. They're saying we can't find 3 positive integers, right? So integers being positive integers being things like 1, 2, 3, 4, 5, 6, right? We can't slot in positive integers for x, y, and z that make that equation true if the n is bigger than 2. So let's have a look at it. If the n is 1, right? X to the 1 plus y to the 1 is equal to z to the 1. Can we make that equation true? Can we find 3 numbers such that x plus y is equal to z? Okay, this is grade 1. Can we find something? Can we find 3 numbers that x plus y is equal to z? Give me 3 numbers. Anyone? You want to talk to the person next to you so you get a bit of confidence before I pick on someone to answer it. Talk to the person next to you. You need to find a number that you can put in for x, a number that you can put in for y, and a number that you can put in for z so that the equation is true, right? If I put in 5, 6, and 7, if I put 5 here, and 6 here, and 7 there, will the equation be true? No, because 5 plus 6 is 11, and it's not 7, right? What are 3 numbers, x, y, z, that you can put in here to make the equation true? Okay, yes. Yes. 2, 3, 5, right? 2 plus 3 is 5. Is that the only one? No. What's another one? Yes. 1, 2? And 3. Yes, beautiful. 1, 2, and 3, right? Because 1 plus 2 is 3. Are there more? Yes. How many more? No. Infinitely more, right? You can keep doing additions forever. So you can see this equation, you can find solutions to it when your n is 1. When your n is 2, you've got x squared plus y squared is z squared. What does that remind you of? X squared plus y squared is z squared. Pythagoras, right? There is your Pythagoras, right? And we definitely know that there are things that work here beautifully, like 3 squared plus 4 squared is 5 squared, right? So for the 1s and the 2s, no problem. We've got lots and lots of solutions. And what is fascinating is that Fermat said, and we now, 300 years later, have been able to prove it's true, that if you try and do the same with a 3, x cubed plus y cubed is z cubed, you won't be able to find any 3 integers to make that true. And the same if it's 4. And the same if the n is 5. And the same if the n is 100. And the same, right? And I mean, that's quite interesting. And you think it should be very easy to prove, right? You feel like you should just be able, I mean, you all can understand this. This is not complicated mathematics. But it turned out to take 300 years and a proof that thick to show that there is absolutely no way you will ever find 3 numbers, 3 integers, positive integers, that can make this true for anything that's 3 or 4 times. And that, this theorem was one of the theorems that Sophie Germain worked on. And she got quite a long way along the way to proving it. She proved it for quite a number of cases. But unfortunately, she didn't prove it in general, because if she had, she would have been. So, to end my story of Sophie Germain, she basically then, she did do some incredible work in mathematics, and she eventually won a prize from the Academy of Sciences in France. So she won one of their prestigious prizes. You know that she wasn't allowed to go to the ceremony, into the place where they gave the awards. Why? She's a woman, right? The only women who were allowed to go were the wives of members. So you had to be married, you know, but even if you'd done the proof yourself as a woman, you couldn't go, only if you were the wife of a member. That was shocking that that level of prejudice against women existed. And so when she died, by the time she died, she had never been awarded a degree. And despite the fact that she had won one of the most a prestigious prize in mathematics, had never ever been able to go and receive it, etc. So, an interesting woman, a pioneering woman, and I'm going to, because that feels a bit depressing, like, hey, you know, women don't count and whatever. But let's just go, I'm going to do a quick, now, fast forward through some of the other women mathematicians that have existed subsequently. Yes?
I'm sorry, the way I just go through the story for a minute. I was wondering as to why it says no 3 positive. Why is it specific on positive? Because I feel that if it would say no 3 positive, then it's implying that negatives can put in, but it wouldn't make any sense.
Yeah, so it is, they are very specifically looking for positive. The one thing they want to exclude with the positives is the use of 0. Because obviously if you put in a 0 for x and a 1 for y, you would be able to get 0 to the power of n is? 0 to the power of n is? 0. 1 to the power of n is? 1. And so if you put 1 in here, you would get it there, right? And then they needed to exclude the negatives because particularly for something like x cubed, right? If I put in a minus 2 cubed, it will be minus 8. 2 cubed will be 8. Minus 8 plus 8 is 0. So it wouldn't be, so that's why they want to exclude the negatives, right? It's only with the positives that you're not going to get to work. Okay, so to whip through, and I've just kind of pulled out a few female mathematicians for us to just take a look at and see how far women have come in this world of mathematics and how it has opened up. So this is a woman, Valerie Thomas. She is still alive as far as I know, but retired at this point. She's an American woman, and she worked for NASA, you know, their space agency in the States, and developed this really, I mean, I have no idea exactly what it is, so please don't ask me too many questions about it. It's a illusion transmitter, and it's something that allows kind of one to see images and create images, etc. from space, and it's now being used in surgery and in 3D TV. And she had kind of 1943 growing up. She still had a lot of resistance from her family to her going into maths and studying maths. They kept trying to push her in other directions, but she was persistent as Sophie and as determined, and has now being celebrated across the world for her achievements and what she's managed to create. I'm not even going to try and pronounce this person's surname, but she is a very famous female mathematician, and unfortunately died really young. She had breast cancer, and so died a few years ago. but she is an incredible mathematician and did a whole lot of work in the areas of hyperbolic geometry and ergodic theory. And she was the first woman to be awarded the Fields Medal. And the Fields Medal, have you heard of the Nobel Prize? So the Nobel Prize is for sciences and for the Peace Prize, etc. And the equivalent of the Nobel Prize in mathematics is the Fields Medal. And so she won the Fields Medal. So first woman to win it, and that means she was basically the top mathematician at that time. And then, just in case you think that it's everybody from across the world, we have incredible women mathematicians in South Africa. So I've just chosen a little selection of a few women in South Africa doing incredible things in mathematics and with their mathematics. Dr. Duba doing work in waves and mixing processes in the planetary oceans. Then you've got Prof. Pillay, she's working in point-free topology. And then you've got Prof. Howell, who's working in algebraic biology. So, and there are many, many more. So if you're looking for women to act as your role models, to inspire, there are plenty of them in our mathematics departments around the country. Let me just watch my time, because I don't want to, I know you've got lots of exciting things to go on to today. I just wanted to then do a little brief run through, and I'm not going to spend a lot of time on this. If you Google the South African Maths Foundation, you will find their site, and they have a very nice info page, which I have taken this off, which talks about the kind of careers that you can do if you have a strong mathematics background. So I thought I'd just take you through some of them briefly so that you can see some of the options open. So there's a whole sort of series of work in Earth and the environment. So things like climate analysts, cosmology, and the environmental scientists, ecologists, meteorologists, right? The people who look at the weather, etc. Population ecologists, looking at populations of animals, biomathematicians, right? So all of those are careers, if you're interested in Earth and the environment, that require a strong mathematical background. I'm just going to caution you, the minimum is a 60% for maths in matric, right? But that is the minimum, right? Many of the universities will require higher than that, so I just don't want to, don't think 60 is good enough. It is the minimum, but that is a requirement. And those are really interesting careers if you have an interest in that. I think engineering and construction, most of us know something about that, right? So there are plenty of engineerings, different kinds of engineerings that do different things. There again, you require a similarly strong mathematics background. Again, a minimum of 60, but many of the universities would be requiring a 70 or 80 for your matric maths for engineering. Then you've got all your IT, information technologies, computer science, etc. Careers, and again, those would lead to many interesting different jobs, and particularly in this new world where we've got machine learning and AI, there is a huge amount of kind of growth and development in this area, but again, you need your mathematics as a backing to get into those. And then finance and commerce, there are a lot of finance and commerce options, career options, that require you to have that mathematics background. So your accountancies, your actuaries, your financial analysts, etc. And again, 60% minimum for your matric maths, but hopefully better, and many, many different career options. Your medical fields, although they're not strictly mathematical, most of them, they do require your maths and science background in order to enter them. And in many of these cases, the requirements go up and up because medicine is a very competitive degree to get into. There's all of this information is on the South African Maths Foundation website. So if you want to have a look at it, it's a very useful place just to get a sense of what options might you have open to you if you are a person who loves maths and is interested in your maths and science, and you want to carry on the trajectory of women who succeed and contribute to our world through their maths and science. So I'm going to end off very briefly just talking about the path I took, which obviously one of the things you can do if you major in maths at university is end up in teaching and research. And so when I finished my maths degree, I continued into postgraduate studies in maths, and then I started lecturing at the University of Cape Town. So I was a lecturer in the maths department at the University of Cape Town for a while. And I realized when I was there that we were not getting sufficient South African learners into the kind of BScs, the engineering, etc., because their matric maths results were too low to allow them in. And that story is still actually quite similar today. That if you have a look at the story, now remember everything that I told you, all of those careers, you needed 60%, above 60%, right? If you're matric maths in order to do it. Can you see these yellow bars are the percentage of learners who pass at 60%? 2% of learners in 2018. And it's hidden behind the bar here, but by 2023 it was only 3%. So although people are passing maths, they're not passing maths with sufficient good passes to open up their ability to go into your BSc or your engineering or your medicines or whatever. We still have a really small proportion of our matrics getting to a level in mathematics. And that distresses me because I love mathematics and I believe everybody can do mathematics. And so I decided it was too late to be working at university to try and help people with maths. Let me go back and start working at high schools. So I started working with a friend who started this organization called OLICO, and we started working in maths education in the high schools. So we developed our own online program, and we employed wonderful tutors, and we've been working in a number of schools to support learners with their maths at high school. But the more I worked with high school kids, the more I also realized that there was a real issue at primary school level, and so I started to learn about what would it take to help people succeed at primary school level so that they'd then be able to go into high school really confidently. And so we started what we call maths clubs at the primary school level, and there we work with young learners in primary schools, where we play maths games and do exciting things like that, in order to get them interested in maths and to lay a good foundation for them to continue. And so that's been what I have been doing then for the last 14 years or so. And been really trying to work with schools. We've built an organization and we've built the materials, etc., to really try and help South African learners succeed. And I do some research in that field as well. And so that basically is my story, and I've even managed to keep to time, which is really impressive for me. But I also I brought along one of my colleagues, Apiwe. So in our high school program, we use computers to help people learn mathematics, but we also use very bright, very able, very incredible young people to work in the classrooms with our learners in order to help them succeed in mathematics. And Apiwe is one of them, and she's been working with me for a number of years now. And I think she really knows what it takes for women to succeed at school in mathematics. And so I asked her just to end off here for me by talking to you a little bit about her journey and what it takes to succeed in mathematics. So, up you there.
So we're gonna, before I even tell you about my journey, I'm gonna try and revive you, right? So just a couple of seconds, né? So I'm gonna put a number here, right? So let me put 5, né? So this is basically some of the stuff that we do at OLICO, but obviously for the younger kids, né? So don't be like, grade 11, right? So this is 5 and we're doing addition. So the energizer is called I give, right? So if I give you a number which is 1, you're going to give me 4 because we are adding 2 5. Right, so you can do any number, preferably we like 5 because we have fluency, we also like 10, it's easier to do, right? Ready? Yes. So I'm going to say I give, and then you guys are also going to say I give, right? Okay, so let's start. I give, I give.
I give, I give.
I give, I give.
I give, I give.
I give you 1.
I give you 4.
I give you 4.
I give you 1.
I give you 3.
I give you 2.
I give you 0.
I give you 5.
I give you 5.
I give you 0.
Right. So at OLICO we make maths very fun. So when you're doing addition and you're busy singing, like that's awesome, isn't it? Yes. Right. So obviously thank you Dr. Lynn for introducing me. So I'm up here. I've worked at OLICO for like a number of years, but obviously my journey didn't stop there, right? So I was a scholar as well. I think my love for maths was basically like I discovered it like around high school because that's when I started being serious. Actually, I need maths for me to be able to get better opportunities, right? So grade 9, obviously practice, consistency is key, right? So I need to work hard. So obviously I was like in a high school and coming from a background that isn't so privileged, I obviously had to then be like, you know what, I need better opportunities so that I can be able to get into university, right? Cool. So grade 9, I'm like, okay, cool, I want to go to a high school that was like very nice, but obviously I needed to like practice maths. I needed to do well in my subjects. I needed to, obviously maths is not, you know, just the only subject that you need to get on top of, so everything matters, but consistency is key, understand? So I was able to get a bursary and then got into a high school that I really liked and was able to pass my matric really well, and then got offered another bursary to get into Wits, right? So at Wits, I did not do mathematical sciences, but I was obviously in BSc. So as Dr. Lynn has mentioned, you have your careers, your BScs, your accounting and all of these other things. All of them require maths. All of them require science, but all of them also require consistency from you. So I was able to get a bursary, got into Wits, did my BSc in biochemistry and genetics, right? So obviously first year, you see all of these subjects and then you think to yourself, but I genuinely like mathematics. And obviously it was then, or rather got an opportunity to tutor at OLICO Maths Education. And then I'm like, actually, I really like, you know, making people understand maths better. So then I was like, okay, cool. Further opportunity, let me start, you know, furthering my studies towards that. So then obviously this year is like my first year in PGCE, so that's like towards teaching in maths and hopefully specializing and hopefully becoming Dr. Lynn. Right? So guys, again, consistency is key, right? And you guys are in grade 11, right?
Yes.
And also I know our teachers are like grade 12, but it starts way back. For you to be able to get into opportunities, it starts way back. You guys have heard of provincial acceptance, right?
Mm-hmm.
Right, so grade 11 marks matter. In as much as we can get our A's, brilliant in grade 12, but our universities look at our grade 11 results. Understand?
Yes.
Okay, so yeah, consistency is key. So please practice, Do everything that you can, work hard, so that I can see you in UP, Wits, or wherever. Yeah? Good luck, guys. Thank you so much.
All right, girls. Thank you so much to Dr. Lynn and Akiwe. I hope their insights have inspired you